Zulm. Java is a very popular programming language. It was created by Sun Microsystems back in 1995. James Gosling is often called the father of Java. The main goal was to create a language that could run on many different types of devices. This concept is known as write once, run anywhere, or WARA. What that means is you can write Java code on one computer, like a Windows PC, and then run that same code on a Mac, a Linux machine, or even other devices without changing it at all. This portability is a huge reason for Java's widespread success and adoption across various industries. It really simplifies development for diverse environments considerably. Java is also an object-oriented programming, or OOP, language. Now, this might sound a bit complex, but it's basically a way of organizing code. It helps make programs more modular and easier to manage. In OOP, everything is treated as an object. These objects have data and behaviors. For example, think of a real-world object like a car. A car has data like color, model, and speed, and it has behaviors like start, stop, and accelerate. Programming in Java involves creating and interacting with these software objects. This approach helps in building large and complex applications systematically, making them easier to update and maintain over time. The importance of Java in the tech world really cannot be overstated. For decades, it has been a cornerstone for developing robust and scalable applications. Many large companies rely on Java for their critical systems. This includes banking applications, e-commerce platforms, and scientific research tools. Its stability and vast ecosystem of libraries make it a reliable choice. By the way, a library is a collection of pre-written code that developers can use. This saves time and effort since you don't have to write everything from scratch. Java's long history means it has a mature community and extensive documentation. Learning Java opens up many doors for aspiring programmers. Because it is so widely used, there is a constant demand for Java developers. Understanding Java also provides a strong foundation for learning other programming languages. Many concepts in Java, like object-oriented programming, are transferable. The language is designed to be relatively straightforward to learn, especially compared to some older languages. It handles many complex tasks, like memory management, automatically. This allows beginners to focus more on a program's logic rather than low-level system details, so this makes the initial learning curve less steep. You might be surprised by how often you interact with Java applications. One of the most significant areas where Java shines is in Android app development. The Android operating system itself has a large part of its foundation built with Java. Most apps you download from the Google Play Store are written in Java or Kotlin, a language that is fully interoperable with Java. So every time you use your Android phone or tablet to play a game, check social media or browse the web, chances are Java is working behind the scenes. This makes Java skills highly valuable in the mobile development industry. Beyond mobile apps, Java is a powerhouse in enterprise-level applications. These are large, complex software systems used by big companies. Think about online banking systems you use. Many of them rely on Java for their security and scalability. E-commerce giants also use Java to manage their massive online stores, process transactions, and handle inventory. These systems need to be reliable and handle many users at once. Java's robust nature and performance capabilities make it an ideal choice for such critical infrastructure. Government agencies and healthcare organizations also depend on Java for their data management systems. Java also plays a crucial role in the world of big data. Technologies like Apache Hadoop and Apache Spark, which are used to process and analyze enormous data sets, are often written in Java. Companies collect vast amounts of information every day. Java helps them make sense of this data, to find trends, make predictions, and improve their services. If you are interested in data science or data engineering, knowing Java can be a significant advantage. Its ability to handle large-scale computations and its extensive libraries for data processing make it a key player in this rapidly growing field. Scientific and research communities also extensively use Java. It is employed in creating simulations, analyzing experimental data, and developing research tools. For example, applications in bioinformatics, which involves analyzing biological data, often use Java. Financial services use Java for trading systems and risk management applications because of its performance and reliability. Even embedded systems like those in Blu-ray players or set-top boxes sometimes use Java. Its versatility means that Java developers can find opportunities in almost any sector of the technology industry. making it a flexible and future-proof skill to acquire. Before you can start writing and running Java programs, you need to set up the Java Development Kit, or JDK, on your computer. The JDK includes everything you need: the Java compiler, the Java runtime environment, JRE, and other essential tools. The compiler, which is called, turns your human-readable Java code into bytecode, which the JRE can understand and execute. The JRE, which includes the Java Virtual Machine, or JVM, is what actually runs your compiled Java programs. Many users might already have the JRE installed to run Java applications, but for development, the full JDK is necessary. The first step is to download the JDK from the official Oracle website or other providers like Adoptium, which is also known as Eclipse Temurin. It's important to get it from a trusted source to avoid any security risks. Navigate to the Download section and look for the latest stable version of the JDK. You will typically find installers for different operating systems such as Windows, macOS, and Linux. Choose the installer that matches your computer's operating system. For example, if you are using a Windows computer, you would download the OR file. Make sure to select the correct architecture, like x64 for 64-bit systems. Once the download is complete, go ahead and run the installer. The installation process is usually pretty straightforward. On Windows, you will double-click the downloaded file and follow the on-screen prompts. You can generally accept the default settings for the installation location and components. On macOS, you might open a file and drag the JDK package to your Applications folder or run an installer package. For Linux users, installation can often be done through a package manager, like or by extracting a downloaded file and setting up environment variables manually. The installer will place all the necessary files in a directory on your system. After installation, it's crucial to verify that Java has been set up correctly. You can do this by opening a terminal or command prompt. On Windows, search for CMD or PowerShell. On macOS or Linux, search for terminal. Once the terminal is open, type the command and press enter. If Java is installed correctly, you will see information about the installed Java version, such as Java version 17.0.1. Then type and press enter. This command checks for the Java compiler. If it also shows a version number, your JDK is ready to go. If you get an error, you might need to set up environment variables, like and manually, which tells your system where to find the Java executables. In Java, variables are like containers that store data values. Before you can use a variable, you must declare it. Declaring a variable means giving it a name and specifying the type of data it can hold. For example, if you want to store a whole number, you would use a data type like. The name you choose for your variable should be descriptive, making your code easier to read and understand. For instance, instead of just using, you might use or. Variable names in Java are case sensitive, so is different from. Java has two main categories of data types: primitive data types and reference or non-primitive data types. Primitive data types are the most basic types available. There are 8 primitive data types in Java, and for whole numbers, and for numbers with decimal points, for single characters like A or 7, and for true or false values. Each type has a specific size and range of values it can store. For example, and usually stores numbers from about -2 billion to +2 billion, while it can store very large or very small numbers with high precision. Let's look at an example of declaring and initializing a variable. To declare an integer variable named, you would write, this tells Java to set aside memory for an integer and call it. To give it a value, you use the assignment operator, which is the equals sign. For example, you can also declare and initialize a variable in a single line. Similarly, for a decimal number, you might write. For a character, it's and for a Boolean. Choosing the correct data type is important for memory efficiency and program correctness. Understanding data types is fundamental because the type of a variable determines what kind of operations you can perform on it. For example, you can perform arithmetic operations like addition and subtraction on numeric types, such as OR. You cannot directly perform arithmetic addition on A and AN without some form of conversion. Java is a statically typed language, which means the type of a variable is checked at compile time when your code is being translated into bytecode. This helps catch many errors early in the development process. This strict type checking contributes to Java's reputation for robustness and reliability in large applications. In Java, all code resides within classes. A class is like a blueprint or, a template for creating objects. It defines the properties, sometimes called data and behaviors or actions, that objects of that class will have. For example, you could define a car class. This car class might have properties like color, model, and speed. It might also have behaviors like start engine, accelerate, and brake. Think of the class as the general concept of a car, describing what all cars have and can do. This organization helps in structuring large programs into manageable and reusable components. Once you have a class, you can create objects from it. An object is an instance of a class. Following our car example, you could create specific car objects like my red Ferrari or my blue Volvo. Each object would have its own values for the properties defined in the car class. For instance, my red Ferrari would have color set to red and model set to Ferrari, while my blue Volvo would have color set to blue and model set to Volvo. These objects can then perform the behaviors defined in the class. Creating objects is a fundamental part of object-oriented programming in Java. It allows you to model real-world entities or even abstract concepts in your code. Methods are blocks of code within a class that perform specific tasks. They represent the behaviors of an object. In our car class, start engine, accelerate with an amount, and brake would all be methods. When you call a method on an object, you're basically telling that object to perform an action. For example, myredferrari.accelerate with an input of 20 would instruct the myredferrari object to increase its speed. Methods can take input values, called parameters, like amount in accelerate, and can also return a value after completing their task. Methods help in breaking down complex tasks into smaller, more manageable pieces, making code easier to write, test, and reuse. So, to summarize, classes are blueprints, objects are the actual things created from those blueprints, methods are the actions that those objects can perform. This structure is central to Java. When you write a Java program, you are essentially defining classes, creating objects from those classes, and then making those objects interact by calling their methods. This object-oriented approach promotes code reusability, since a well-defined class can be used to create many objects. It also improves maintainability because changes to the internal workings of a class do not necessarily affect other parts of the program, as long as the way objects interact remains consistent. Let's write your very first Java program. Traditionally, the first program beginners write is one that displays the message "Hello World" on the screen. This simple program helps you verify that your Java setup is working correctly and introduces you to the basic syntax of a Java program. To start, you'll need a plain text editor like Notepad on Windows, TextEdit on macOS, or more advanced code editors like VS Code, IntelliJ IDEA, or Eclipse. For now, a simple text editor is perfectly fine. Avoid word processors like Microsoft Word, as they add formatting that interferes with code. Open your text editor and type the following code exactly as shown. Pay close attention to capitalization, braces and semicolons, as Java is very precise about these things. Public class hello world, public static void, main string args, system out println hello world. Let's break this down. The line declares a class named hello world. All Java code must be inside a class. The name of the file must match the public class name, so you will save this file as helloworld.java. The line is the main method. This is the entry point of your program. When you run the Java application, the code inside this main method is executed first. The statement is what actually prints the message to the console. After typing the code, save the file as helloworld.java in a directory of your choice. Make sure the file extension is Java. Now, you need to compile this Java file into bytecode. Open your terminal or command prompt. Navigate to the directory where you saved helloworld.java using the cd or change directory command. For example, if you saved it in a folder named Java Programs on your C drive, you might type cd C Java Programs. Once you are in the correct directory, type the compilation command javac helloworld.java and press enter. If there are no errors in your code, this command will create a new file named helloworld.class in the same directory. This class file contains the bytecode. Now that you have the compiled bytecode file, helloworld.class, you can run your program. In the same terminal window, type the command java hello world and press enter. Remember, you don't include the .class extension here. If everything is correct, you should see the message hello world printed on your screen. Congratulations, you have successfully written, compiled, and run your first Java program. This process of writing, saving, compiling, and running is the fundamental workflow you will use for all your Java development. Understanding these steps is crucial for any aspiring Java programmer. One of the most common mistakes for beginners is related to syntax errors. Java is a case-sensitive language. This means my variable is different from my variable or my variable. Using the wrong case for keywords, class names, method names, or variable names will lead to compilation errors. For example, system.out.println must be capitalized exactly that way. System.out.println will not work. Another frequent syntax issue is forgetting semicolons at the end of statements. Each executable statement in Java must end with a semicolon. Missing braces or having mismatched pairs for classes, methods, or control structures is also a common source of frustration. Another area where beginners often stumble is understanding the difference between the assignment operator, which is the single equals sign, and the equality comparison operator, which is the double equals sign. The single equals sign is used to assign a value to a variable. For example, int x equals 10. The double equals sign is used to compare two values to see if they're equal, typically in conditional statements like if x double equals 10. Using the single equals sign when you mean double equals can lead to logical errors that are hard to debug because the code might still compile but not behave as expected. Always double-check your operators when writing conditions or assignments. Null pointer exceptions are a classic runtime error that many Java beginners and even experienced developers encounter. This error occurs when you try to use an object reference variable that has not yet been initialized, meaning it points to null as if it were pointing to an actual object. For example, if you declare an object string name but don't assign it a value like name equals Alice, and then try to call a method on it, like name.length, you will get a null pointer exception. To avoid this, always ensure your object variables are properly initialized before you use them, or check for null before attempting to access their members. Finally, mismanagement of file names and class names can cause issues. In Java, if a class is declared as public, the .java file name must exactly match the class name, including capitalization. If you have public class myprogram, the file must be saved as myprogram.java. If they don't match, the compiler will complain. Also, when running a compiled Java program using the Java command, you use the class name that contains the main method, not the file name. For example, Java myprogram, not Java myprogram.class. Paying attention to these details from the start will save you a lot of time and prevent unnecessary compilation and runtime problems. The most important tip for getting better at Java is to practice consistently. Reading books and watching tutorials is a good start, but programming is a practical skill. You learn by doing. Try to write code every day, even if it's just for a short period. Start with small, simple programs that modify the hello world example. For instance, try printing different messages or using variables to store parts of the message and then print them. As you learn new concepts like loops or conditional statements, immediately apply them by writing small programs that use these features. This hands-on approach really helps to solidify your understanding. Another great way to practice is by working on small projects. Instead of just writing isolated snippets of code, think of a simple application you could build. This could be a basic calculator, a to-do list application, or a simple text-based game. Having a project gives you a goal and forces you to integrate different concepts you've learned. You'll encounter problems and have to figure out solutions, which is an invaluable part of the learning process. Don't be afraid to start small. The complexity of your projects can grow as your skills improve. Online platforms often suggest beginner-friendly project ideas. Reading other people's code can also be very beneficial. Look for open-source Java projects on platforms like GitHub. Start with small, well-documented projects. Try to understand how they are structured, how different classes interact, and what coding conventions are used. You might not understand everything at first, but you will pick up new techniques and see practical applications of Java concepts. You can also learn from the way experienced developers solve common problems. This exposure to different coding styles and solutions broadens your perspective and helps you write better code yourself. Don't be afraid to make mistakes and ask for help. Everyone makes mistakes when learning to code. Errors are opportunities to learn. When you encounter an error, try to understand the error message. Often the compiler or runtime environment gives clues about what went wrong. Use online resources like Stack Overflow to search for solutions to common problems or to ask questions. Join online communities or forums for Java beginners. Explaining your problem to others can often help you clarify it in your own mind, and the Java community is generally very supportive and helpful to newcomers. Learning Java is a significant investment in your future career. It is one of the most in-demand programming languages in the world. Companies of all sizes, from startups to multinational corporations, actively seek Java developers. This high demand translates into numerous job opportunities across various sectors, including finance, healthcare, e-commerce, telecommunications, and technology. Whether you want to develop mobile applications, build large-scale enterprise systems, work on big data solutions, or create web services, Java skills will make you a valuable candidate in the job market. The versatility of Java ensures a wide range of potential career paths. The earning potential for Java developers is also quite attractive. Due to the high demand and the complexity of the systems often built with Java, developers proficient in this language typically command competitive salaries. As you gain more experience and specialize in areas like enterprise Java, Android development, or specific frameworks like Spring, your market value can increase even further. Many companies also offer excellent benefits and opportunities for professional growth to retain skilled Java talent. So, learning Java not only opens doors to jobs, but also to a financially rewarding career path. Beyond direct employment as a Java developer, understanding Java can be a stepping stone to other roles and technologies. Many modern programming languages such as Kotlin, Scala, and Groovy run on the Java virtual machine and can interoperate with Java code. Knowing Java makes it easier to learn these languages. Furthermore, concepts learned in Java, particularly object-oriented programming principles, are applicable to many other languages like C# or Python. This foundational knowledge makes you a more versatile and adaptable programmer, capable of picking up new technologies as the industry evolves. Finally, the Java ecosystem is vast and mature. This means there is an incredible amount of resources available for learning and development, including extensive documentation, active online communities, and a plethora of libraries and frameworks that can speed up development. This strong support system makes it easier to continue learning and growing as a Java developer throughout your career. The longevity and continued evolution of Java suggests that it will remain a relevant and important technology for many years to come. By choosing to learn Java, you are equipping yourself with a skill set that is both powerful today and well positioned for the future of software development.